Well, now that we have met the z-score and have a kind of the idea of what it is, I'm going to help you understand more about it. So this is kind of z-scores revisited to help you understand that the z-score can be easily calculated and it gives us a lot of information. In the last session, we met this term, the z-score, a way of expressing the location of a datum in light of mu and sigma to allow interpretation of the data's location in the population. In light of the mean and the standard deviation, we can use a z-score to interpret the datum's location in a population. If we were talking about a sample, we would be using X bar and S. You cannot forget anything. You have to remember everything. Do you recall this discussion? We had a raw data point of 150, and in our data set, mu was defined as 100, and the standard deviation was defined as 20. So the z-score for 150 in this situation is 2.5. That one is easy to calculate because it turns out that 150 in this case is 2.5 standard deviations above the mean. We see that a raw data of 150 is 2.5 standard deviations above the mean. Very easy to calculate and very easy to visualize. What about a z-score, though, of 92? If we have 92, how far is it below the mean? It's actually, the mean is 100, 92 is below the mean. It's somewhere between, it's not one full standard deviation below the mean. It's just more difficult to calculate. We need a formula. We need a formula to find z-scores. And the formula is the data minus the mean divided by the standard deviation. Not very difficult to do. Obviously, this is for a population because we have mu and sigma, and we have kappa x, which stands for a data point in the population. If we were using the sample, the z-score for a data point would be x minus x bar over s. This is fairly easy to calculate. The names, of course, were changed to protect the innocent. Now, what if is the z-score of 92 when mu is 100 and sigma is 20? Well, what we do is we plug in 92 for kappa x, we plug in 100 for mu, and we plug in 20 for sigma, and lo and behold, we have 92 minus 100 over 20, which turns out to be negative 8 over 20, which is negative 0.4. Now, I want you to notice that when the datum was below the mean, the z-score is negative. When the datum is above the mean, the z-score is positive. These are kind of fun. I mean, that's not very hard to do. We see that our x of 92 in this specific set has a z-score of negative 0.4. The number 92 doesn't really mean anything. But when we say a z-score of negative 0.4, we know immediately that it's 4/10 of a standard deviation below the mean. If we say a score of 150, it doesn't mean anything. But when we say the z-score is 2.5, we know it's 2.5 above the mean. The z-score gives us the location of a data set. Those below the mean are negative, and those above the mean are positive. And they have three concepts to remember. Z-score, a way of expressing the location of a datum in light of the mean and the standard deviation, to allow interpretation of the datum's location in the population. What a z-score really is the number of standard deviations that a datum lies above or below the mean. If it's above the mean, it's positive. If it's below the mean, it's negative. That's really pretty easy to comprehend. You're climbing the ladder. Now, friends, you've got this. You see, I told you it isn't devastating. We're going to use software. We're going to use Excel. We're going to use SPSS, and you're going to learn what these terms are, and then you're going to be able to find them using software, and then you'll be able to interpret them. And statistics for you will be a lot of fun. Thank you. We'll move on here in just a moment.